All right, kiddos, here we go with Earth tides. This is the last one in Unit 9. After this, you will be having an assessment. Look for that assessment in Schoology. I will be opening that up in a day or two. You have until the end of the 9 weeks to take the assessment. Of course, it's always best to try to get it done quickly. So let me go ahead and present this. Earth's tides. What causes the tides? What are tides? Who knows? That's why we're here in science today. Our wonderful SOL for today, notice H, the cause of tides, something that you are expected to know to take with you to seventh grade and leave sixth grade with. Tides are daily changes in the level of ocean water. I love going to the ocean. I feel it's almost like it's not a summer unless your toes get into salt water. High tides are okay, but I really love low tides. I just love the ocean. I'm the type of person that I'm never laying on my blanket. I'm always walking around in the waves and looking at everything. And I really like quiet beaches. I don't like overly crowded beaches. Figure that out as we do this. What causes tides? Tides are caused by the difference in gravitational force of the sun and the moon across the earth. This is called a tidal force. So we get tides because of the sun and the moon. The moon's tidal force is greater than the sun's. So what happens? Every large object or everything has a gravitational pull. The moon does have a gravitational pull. It's less than the Earth's. The Earth, we pull the moon towards us, and that's what keeps it in orbit. But the moon's still pulling back. And what it pulls back is water. And remember, the sun is pulling on us as well. So the sun is also pulling water because the water is a liquid. The earth is a solid object. We are a terrestrial planet. You'll learn about that later. So the water moves when the earth isn't moving. The water will move more. The gravity from the moon pulls the earth and water more easily pulled than solid ground. I don't know if I wrote that right, or grammatically it's awkward. The side of the earth that faces the moon has water poured toward the moon. The earth is also pulled to the moon so the oceans away from the moon have a high tide too. Yeah, that sounds confusing. Let's look at how tides work. Trust me, you are going to see this. Now, this is kind of a double video I'm going to show. Wait, hold on. Three. High tide is when the water level is higher than normal. Low tide is when the water level is lower than normal. Tidal bulges form as the moon pulls water towards it. So here comes the tides video that I was talking about. Before we watch it, let's take a look at this picture. Here's the water on the earth. It's not really that deep, but it gives you an idea. The moon is pulling water in one direction, the sun's pulling water in one direction. And these two guys right here normally are not lined up. So we can have the moon pulling one way, the sun a little bit this way, but the moon is what's causing the tides. When you go to the ocean and you see a moon overhead, chances are you're getting very close to or are at high tide. Well, the moon should be directly overhead. So let's watch this. Let's see if this guy does a better job of explaining it than me. Why are those boats on sand? Oh my goodness. How about that?
This shows 12 hours at the famous Bay of Fundy in Nova Scotia, Canada. It's the biggest tide change in the world. But what force could move such a massive body of water? Gravity. Here's the Earth rotating on its axis every 24 hours. We'll now draw the Earth as a diagram with its surrounding layer of ocean. And to the right is the silvery moon. Everything is attracted to everything else in the universe with the force of gravity. So the moon is attracted to the Earth, and the Earth is equally attracted to the Moon. Notice that the two force arrows are the same length, showing that gravitational attractions are of equal strength. But we're only interested in the force on the Earth here. The Moon pulls on the ocean closest to it and makes it bulge outwards. When the Earth rotates, the sea level is higher at this point in its rotation, causing a high tide. And a low tide where the oceans don't bulge. So you'd expect one high tide each day.
Nope.
But here it gets interesting because there are 2 high tides a day. How come? This is because the strength of gravity is greater when objects are closer. We'll call the location of the ocean on the near side of the Moon, point A, at the centre of the Earth, point B, and at the far side ocean, point C. The strength of the Moon's gravity is strongest at A because it's closest to the Moon. So the part of the ocean that bulges towards the Moon most is at A. But the Moon's gravity also pulls on the Earth, moving it towards the Moon as well. This has 2 effects. First, it makes another bulge at C. Second, it fills in the bulge at A, but not completely, because A has moved further towards the Moon than B. Lastly, the far side ocean at C is also attracted to the Moon, but it moves least because the Moon's gravitational pull here is at its weakest, being farthest from the Moon. This leaves a partial bulge at C, though not as big as the one at A. Now we can see why, when the Earth rotates through 24 hours, it goes through 2 high tides and 2 low tides. But there's another surprise. By the time the Earth has rotated once and arrived back at its original position, the Moon has moved on a bit because it's orbiting the Earth at the same time. That means that the Earth has to catch up with the Moon, so the next day's high tide is about 50 minutes later. The Moon rises and sets about 50 minutes later too, because the Earth has to catch up with its orbiting Moon. You can even test this by timing the moonrise or moonset from one day to the next. Or check out some tide charts
High
to
tide,
see if the
low
tides
tide.
obey this rule too.
All right. Okay, I really need this too. There we go. Okay, so there we see the tides being pulled. Tidal range, the difference between the levels of ocean water at high tide and low tide, kind of like your range in math, highest number, lowest number. But there are different types of high tides. There is something called a spring tide. A spring tide is a tide that have the largest daily tidal range. That means the tides are going to be extremely low and extremely high. Neap tides, tides that have the smallest daily tidal range. You're still going to get high tide and low tide, but it's not going to be as high as it would be during spring tides. What are 2 kinds of tidal ranges? Spring tides happen when the moon is between the sun and the earth, or on the opposite side of the sun. They all form a straight line. Neap tides are when the moon, sun, and earth form a right angle. So here we have a picture of a spring tide. Spring tide is sun, moon, earth, and they've got to be lined up because remember the sun's pulling too. So we have extra pull, so those tides are going to be extra high. Neap tide, it forms a right angle. So right now, some of the water is being pulled towards the sun, some of the water is being pulled towards the moon. Kind of confused. So the tides are not that high. So let's take a look at spring and neap tides.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about what causes tides. Tides are the rise and fall of sea levels caused by three items: gravitational force of the moon, the sun, and the rotation of the earth. Gravity is the force that pulls everything in the universe towards everything else. Even though the moon is much smaller than the sun, the moon's pull has a much more pronounced effect on the Earth's ocean because it is closer than the sun. The moon exerts around 2.5 times more force than the sun. On the side of the Earth that's facing the moon, the pull of gravity causes oceans to bulge outward. On the other side of the Earth, the moon's pull on the solid ground causes the oceans to bulge there. The Earth rotates on its axis, so this bulge is constantly changing location. The moon thus tends to stretch the Earth slightly along the line connecting the Earth and the moon. The solid Earth deforms a bit, but the ocean water, being fluid, is free to move much more in response to the tidal force. Where the bulge is bigger, it's high tide. Where the water doesn't bulge, it's low tide. In this picture, you can see the difference between high and low tide.
That's a dramatic
The moon's
one.
orbit around the Earth also causes tidal changes. Most places get 2 high tides and 2 low tides each day. Approximately twice a month, around new moon and full moon, when the sun, moon, and earth form a line, the tidal force due to this alignment is at its maximum, and the tide's range is also at its maximum. This is called spring tide. When the moon is at first quarter or third quarter, the sun and moon are separated by 90 degrees, and the solar tidal force cancels the moon's tidal force. At these points in the lunar cycle, the tide's range is at its minimum. This is called neap tides. So there we go, a bit of information about tides and why we have them. Thanks for watching, and Moo Moo Math uploads a new math and science video every
And thank you, Moo Moo Math. All right, so there's that picture again. What causes tidal cycles? In many places, there are 2 high tides and 2 low tides each day. The cycle is about 24 hours and 50 minutes. So we're hearing stuff over and over, so this is starting to stick in your head. So the high tides and low tides for each day are slowly changing from day to day. So this is a tidal chart right here. Whenever you go to the beach, it's nice to look like, hey, what's the tides going to look like? The high tides. Here you see 2 high tides each day. One was first thing in the morning, one was at night at this particular beach. The moon was a new moon. No, that's a full moon. Wait, goes yeah, that's a new moon. New moon, waxing crescent, first quarter, waxing gibbous. We learned about that last time. Full moon. So here we see, and look, there we see how high these tides are. And as you can see, it's a little bit different. I don't think someone gives the range. You have 2 lows and 2 highs. So here, if you start your vacation on the 1st, your high tide's at 9 o'clock. But when you leave the next Saturday, high tide's at 2 o'clock. So tides. Now here we see this is an example of tides. As we look at this rock formation, We see like some erosion in certain parts and we don't see in other parts. There are no plants on the ground right here for some reason, but all these people are walking around. This is low tide. This is when it will be very interesting to explore and see sea creatures. So let's watch how this works. So here we are at low tide. We see the sun moving, people hanging out. Ooh, look at all this fun stuff. This is a popular place. I like to go here. Uh-oh, here comes the high tide. And here come the kayaks. And there's high tide. So, and then it goes back down to low tide. So this area would have 2 high tides a day and 2 low tides a day. If you want to explore for sea creatures, here are the great spots right here. High tide, not quite as good. Come walk on the ocean floor. Venez marcher sur les fonds marins. For those of you taking French, I probably butchered that. Whoops, I don't want to do that. There we go. And there's the tides. Here's another one. Kingsport, Nova Scotia. You can kind of see where you can predict where the spring tide would come to. Because you see where this erosion is. Not all high tides reach the highest spot. So there a low tide goes out, slowly goes out, keeps going out. Goodness sakes. And we might, are they going to re-show it coming back in, or is this all we got? Oh my gosh, it keeps going out. That's crazy. So this was 6 hours. That's 6 hours, 52 seconds. So 6 hours would have been the difference between the highest tide and the lowest tide. Nice little solid little video. Here's a time-lapse tide coming in again. I think this one is fun. This should not be. Okay, so here we go. I guess that's the biggest screen we got. Here's a little pool of water. Oh, look, there are people walking. But you can kind of predict, because we don't have that much plant growth right here, what's about to happen. It fills up. And look, they're using it as a little swimming area. That's a pretty cool area. I like that. Gotta be careful swimming around those rocks, though. Don't want to get your foot caught. And that might be the highest of the tide right there. And there it goes. So, summing up, in many places, 2 high tides and 2 low tides occur every day. There are 2 types of tidal ranges, spring tides and neap tides. Spring tides are the highest range. You're going to have the highest tides at spring tides. Neap tides, you're still going to have high tides, but it's not going to be that big dramatic range. Gravitational effects of the moon and sun cause tides. So tides are fun. This is, like I said, science is the explaining of how our world works. And thousands of years ago, when people would go to the ocean, they would wonder, why does the ocean go away? Why does the ocean come back? Is there a cycle? Is there a pattern? Why is this happening? They figured it out, and now you have high tides and low tides. And that is the video. All right. You might see that something might have been added right now. So let's take a look at this. You guys probably can't see that. What is a king tide? No thanks. A king tide is a popular concept of exceptionally high tides, normally occurring a new or full moon when the moon is at its perigee or during specific seasons around the country. So it is a spring tide during a specific season is a king tide. You click the link, you'll figure that out. So why, Mr. Demarath, did you just add that last second?
I'm asking for your help. Chuck?
There is a stranger who comes to this village from the sea. He comes in the winter when the people are hungry. He brings fish. He comes on the king tide.
King tide. So if you want to know what a king tide was and were forever confused, now you know. So I will leave you with that. Thank you, students.